In this video, we're going to take a look at collecting like terms. Now, for collecting like terms, essentially what we're doing here is just simplifying. So there's two examples here that we'll run through. These are quite straightforward examples, and as we go through this video, the examples should get more complicated. So let's start with the first one here. We're asked to simplify 2a plus 5a plus a. Now, when we're collecting like terms here, when we say term or terms, what we mean here is the variable, or if we have more than one variables that we're working with. Now, in the case of this first example here, the only variable that we have is the letter a. So in that case, what we need to do is consider the number in front of each letter, okay, or in front of the variable a that we're working with here. And the number in front, we call that the coefficient. So I've got 2a plus 5a plus a. And in front of this a here, we don't write it, but there's a 1. So what I've actually got here is 2a plus 5a plus 1a, okay? And if you find that it helps to write the 1 here, make sure that you do that as we work through this video. So to collect these terms here, all we need to do is add these numbers in front here, the coefficients together. So I've got 2 plus 5 plus 1, so that would give me 8 there. So in total, what we've got here is 8a. I've got 8a because what I've got is 2 lots of a, and then I add another 5a to that 2a, that would give me 7a, and then we add one more a to give us 8a there. Okay, so that's our solution to the first one. Doing the same now with the second one, but what's more complicated here is we have this subtraction here to deal with. So we're asked to simplify 3x plus 2x minus 4x. Now it doesn't matter which way we do this, whether I do 3x minus 4x first and then add the 2x, whether I do 2x minus 4x and then add 3x, completely doesn't matter, and that's just a preference thing, but generally I prefer to work left to right. So if I start with the 3x and then add 2x, that would give me 5x. So 3x plus 2x is 5x. And then we've got minus 4x. Okay. So 5x minus 4x. So again, we just take the coefficient here, the number in front. 5 minus 4, that would give me 1. So we just get 1x here. So 1x. But normally we would just write that as x. Okay. If the number in front is 1, the coefficient is 1. And we just write the variable. So that's going to be equal to x there. Okay. And that's our solution to the second question. Moving on to two more examples here. Getting more complicated now because what we can see for this one here is that we have now two variables. I've got the variable x here, and we have the variable y. Now what I need to do here to collect the like terms is group the same variable together. So what I've got here is 2x minus 4x. So I'll put the x's together here. So 2x minus 4x. And make sure that you take the sign here. So because this is minus 4x, we do include the minus here. Don't change that to a plus. That would be incorrect. And then we've got 5y here. So this is positive 5y. We've got the plus in front. So plus 5y. And then I've got a plus y here at the very end. So plus y as well. And now what we do is we collect like terms like we did for the previous two examples. So I've got 2x minus 4x. So that's 2 minus 4. So that would give me minus 2x. So that's minus 2x. Now we move on to the variable y here. So I've got plus 5y, so that's positive 5y, plus another y here. So remember, y is the same as 1y. So in other words, what I've got then is 5y plus 1y. Adding the coefficients together here, so 5 plus 1, that would give me 6. So we've got 6y there. Okay. So I get minus 2x plus 6y, and that would be our solution. If you prefer, you can write the positive term first, so we could write this as 6y minus 2x. Okay, just changing the way we write those. That is absolutely fine. Both of these are correct, it's just a preference thing. Generally, we prefer to write the positive term first, but again, this doesn't matter at all. Okay, so either of those, absolutely fine there. Moving on to the next one now, and what makes this a little bit more difficult is we now introduce squared terms. So I've got 3y squared plus 4y minus y squared plus 2y. Now this can cause confusion when we're working with the same variable, such as y here, and now we've got y squared. But we have to be slightly careful, so we think of these as different terms. So I've got 3y squared minus y squared. So those are the terms that we will collect together. So let's just put those together to start with. So 3y squared minus y squared. We've then also got 4y plus 2y. So 4y plus 2y. So here now what we need to do, just like we did with this one here, we've collected the terms together, or we've grouped the correct terms together. Now we just need to collect those like terms. So here, what I've got is 3y squared minus y squared. So this minus y squared here, remember, we don't put the number in front, but that is a 1. So what I've got then, if we do it over here, is 3y squared minus 1y squared. Again, we just consider the coefficient here, the number in front. So 3 minus 1, so that will give us 2y squared. Okay, so we get 2y squared there. So we'll just write this underneath to start with. So that's 2y squared. And then what I've got here is 4y plus 2y. So again, just consider the coefficient, the number in front. So 4 plus 2, that will give us 6. So we get 2y squared plus 6y there. Okay, so we'll put our solution down here. Okay, so that's our solution to that example there. Let's take a look at a few more examples now, and what I'm going to introduce with this question here is the idea that we can collect like terms through multiplication. So let's start with this one here first. So we're asked to simplify y squared plus y squared plus y squared. Again, we're just collecting like terms here. The variable that we're working with is the same throughout, so y squared plus y squared plus y squared. In front of each of those y squares there will be a 1. So what I've actually got here is 1y squared plus 1y squared plus 1y squared. So once I collect these like terms together now, because we're adding, we just add the coefficients together. So what I've got then is 1y squared plus another 1y squared, so that will give me 2y squared, and plus 1 more y squared to give us 3y squared. Okay. When we're adding, remember we don't touch the power. Okay, so this wouldn't become anything like y to the 6 or anything like that. Keep the power the same. Okay. Now this contrasts to the second example here where we're multiplying. Because when we multiply, there's two things to consider here. We have to consider the coefficient, the number in front, but we also have to consider the power of the variable. So let's just write this out here. So I've got a times a times a. Now, like I said, there's two things to consider here. There's the coefficient, so the number in front. Now, because this is just a, that would be a 1 in front. So I've got 1a times 1a times 1a. Okay. But I also have to consider the power. Now, similar to how we just put the number in front, the coefficient, we need to do the same with the power. And because this has no power given, that doesn't mean it's 0. What it actually means is it's just a power of 1. So this is 1a to the power of 1, 1a to the power of 1, and again, 1a to the power of 1. Okay. So to start with, what we do is we multiply the coefficients together. So I've got 1 times 1 times 1. So that will just give me 1. So we know the coefficient here will just be 1. Now we work with the variable here. So I've got a. Now when we multiply, so this is where this can cause confusion. We don't multiply the powers, we add these powers together. Okay. So this goes back to, or this goes to a topic that we haven't formally covered yet, but this is to do with indices. So what I do now is I add these powers. So I've got 1 plus 1 plus 1. Okay, so 1 plus 1 plus 1, that would give me 3. So what I get here is 1a to the power of 3. But because this is a 1 here, the coefficient is 1, we don't generally write it. So we'll just leave that as a to the power of 3 or a cubed. Okay, that would be our solution to that example there. And finally, let's take a look at this one here where we've got j plus j plus j plus j. Again, we don't do anything with the powers because we're only adding here, but we just take into account the coefficient. So in front of each of these j's, there'll be a 1. So I've got 1j plus 1j plus another 1j and plus one more 1j here. So in total, what I've got then will be 4j. Again, don't touch the power. We only do that when we're multiplying. So again, let's take a look at some more examples here now with multiplication. And now introducing the idea of dividing. So let's begin with this one here. So we need to simplify 4c times 3d. So in this case here, what we need to do now is multiply the coefficients together to start with. So 4 times 3, well, that would give me 12. So we're going to get 12 there. Now, because the variable that we're working with here, or the variables in this case, because we have more than one, are different, in this case then, what we do is we multiply those together. Now, because we don't know the actual value of c or d, we just write those as a product. So what we do is we write this as 12 times c, so just 12c, and then times that by d, so we put the final variable in here, so we get 12CD, okay? And that would be our solution in its simplest form. So there you can see the process is quite straightforward. Just remembering the little rules that we have to be slightly careful with. Let's take a look at one more example here for multiplication, and then we'll take a look at this division one here. So rest to simplify, 2i times 3j times 4k. Again, let's start by multiplying the coefficients here. So 2 times 3 would be 6, times that by 4, so 6 times by 4, and that will give us 24, okay? So the coefficient of our final solution here will be 24. And now again here we've got three variables. In this case we've got I, j, and k. We don't know what I, j, and k represent, they're just a value. So in this case, when we multiply those together, just like we did with this one, we write those as a product. So that's going to be I, j, k, like so. Okay, so we get 24, I, j, k there. Okay, and that's our solution for that question there. And let's take a look at the idea now of division. So we're asked to simplify 12a divided by 4. And again, just like we've seen with addition, subtraction, and multiplication, we consider this now with the idea of the coefficients here. Now in my denominator, we just have a number. So there is technically no coefficient because we have no variable. But what I'm going to do here, I'm going to take the coefficient of a, this 12, and divide it by 4. Okay, so 12 divided by 4, that would be equal to 3. How many 4s go into 12? Well, that would be 3. So what I get then here is 3a there. Okay, the a still remains. We haven't divided that by anything, so we just get 3a. Okay, and that's our solution to that example. So to finish with here, let's take a look at 3 more examples. Now, for the first one here, we're asked to simplify 7h plus 3h over 2. So where do we begin with this? Well, to start with, what we want to do here is collect like terms in the numerator, so the top of the fraction here. So this should hopefully be nice and straightforward. 7h plus 3h, just add the coefficients together. So that'll give me 10h. So we get 10h over 2, okay? And just like we saw with this division example here, we have something that looks pretty similar now. So I've got 10 times h and we divide that by 2. So all we consider here now is the 10 divided by 2. So 10 divided by 2, that would give me 5. So we get 5h there, okay? And that's our solution to that question. What I've got here now is a product of two variables. So like we can see here, xy minus 5 lots of xy plus 2 lots of xy. And we consider this now as essentially one term. So I've got xy minus 5xy plus 2xy. So we're only working with xy here, so we can go straight into collecting those terms. So in this case, we don't write in front, but this xy here, there's a 1. So I've got 1xy minus 5xy plus 2xy. Again, the order doesn't matter in which we do this. So I'm going to work from left to right. So 1xy minus 5xy, so that's the same as 1 minus 5, or minus 5 plus 1, whichever you find easier. In that case, that'll give me minus 4xy. We get minus 4xy there. And don't forget the plus 2xy. And again, we just collect like terms here by considering the coefficient. So minus 4xy plus 2xy is the same as minus 4 plus 2, giving me minus 2xy there. Okay. And there we have it. So that's our solution to that example. And one more to finish with here, again, where we're working with a product as one term here. So 5ab minus 2ab minus ab. So again, we don't write in front of this AB, but that will be a 1. And I would recommend, again, just writing that if you find it easier to visualize. So I've got 5AB minus 2AB minus 1AB. And again, the order doesn't matter here, but we're only working with this one term of AB, so we can go straight into collecting like terms. Well, 5AB minus 2AB, that's the same as 5 minus 2, so that will give me 3AB. So we get 3AB. Then we've got minus 1ab. So 3ab minus 1ab, well, that's the same as doing 3 minus 1, and that would give me 2 there. So we get 2ab, and there we have it. So that's our solution to the final example. And that actually brings us to the end of this video on collecting like terms.